will be looking at lesson 7.4. I can calculate problems involving the area of a rhombus, trapezoid, and parallelogram. Before we start, let's look at some jokes. This is me trying to remember someone's name a minute after they tell me. Here I am. Here I am. Here I am. Next joke. Here's a little lizard, and then there's some Pokemon, and it says giving him a positive role model. Here's a picture of a dad challenging his kids to draw him while he takes a nap. Before we start, we have to look at some vocabulary. The first vocabulary word we have to look at is a quadrilateral. Say quadrilateral.
Quadrilateral has four sides, is two-dimensional, is closed, and has straight sides. For a rhombus, opposite sides are equal, and opposite sides are parallel.
So now we're going to play a song about a rhombus. So enjoy the song.
I like that rhombus on your necktie. Uh-oh, that is a snake. There's a rhombus on my Argyle sock. There's a rhombus on my Argyle sweater. There's a rhombus on that diamondback snake. Rhombus. Oh, you better not pet her. I saw a rhombus-shaped kite flying up in the sky. I saw a rhombus-shaped marking on the head of a horse. I saw a rhombus-shaped sandwich at a fancy party, and a rhombus-shaped sign that said baby on board. A rhombus is a diamond with all sides the same length. You can measure it. You can ride a bus, but have you ever ridden a rhombus? This playing card has a diamond on it. Rhombus. I prefer to call it a rhombus. Go fish. See a rhombus on a jeweled crown. Run a rhombus when you hit a home run with a rhombus. You can draw a manta ray. A rhombus is all kinds of fun. It's a rhombus.
Did you like that song? That was a good song. The next vocabulary we're going to talk about is a parallelogram. A parallelogram is a quadrilateral with pairs of parallel sides. Quadrilateral. Remember, a quadrilateral has four sides and is two-dimensional, closed, and has straight edges. Straight sides.
It's a quadrilateral with two pairs of parallel sides.
I can be a square or a rectangle, or I can lean over at an angle. I am a parallelogram. I am a parallelogram. Opposite sides are parallel, and that is how you can tell I am a parallelogram. I am a parallelogram. My four sides are straight, but the angles at the corners they make aren't always 90 degrees. Measure them and you'll see adjacent angles add up to be 180 degrees. I am a parallelogram. I am a parallelogram. My four sides are straight, but the angles at the corners they make aren't always 90 degrees. Measure them and you'll see I am a parallelogram.
Did you like the song on parallelograms? That was funny, huh? Finally, our last vocabulary today is a trapezoid. A trapezoid is a quadrilateral. There's that quadrilateral word again. It's a quadrilateral with one pair of parallel sides. Remember, parallel lines go on forever and ever and never touch. See how this parallelogram has two pairs of parallel sides? And a trapezoid has one? Can you tell the difference between a trapezoid and a parallelogram? Think for a second. Yep, this has two pairs of parallel sides, and this has one pair of parallel sides. And one last song. It's the Trapezoid song. Enjoy the song.
Everybody knows what it means to be you. A rectangle, 4 sides, 4 corners to view. They know the qualities of my many-shaped brothers, but no one knows who I am, not like these others.
Don't be so sad, my friend, you should have pride. They will fall fast for you once they have tried.
Cone is a party hat, cube can play dice.
But you've got 4 sides to you, I think that's nice.
Cylinder is a can, ready to drink.
You're a great popcorn box, that's what I think. Be proud, my trapezoid, you're a rowboat. 1 pair of parallels, but you can float.
I'm not like your square, but I'm a jewel. I am a trapezoid, different and cool.
For more songs, games, and original stories, visit Brainsy.com.
Did you like that song? That was a funny song, huh? Okay, so we have to look at 3 steps here to figure out the area of the following shape. So the first thing we want to do is we want to name this shape. What shape is this? It's a trapezoid. Trapezoid. Determine what formula to use. What's the formula? 1/2 height times base 1 plus base 2. Now plug the numbers into the formula. We have 1/2, height is 5, base 1 is 15, and base 2 is 25. Here. Alright, so let's start to simplify our formula. 15 plus 25 is 40. Okay. Because of the commutative property, what I'm going to do is I'm going to multiply 40 times 5 and get 200. And half of 200 is 100. So then my answer is 100 inches squared. Let's look at the following shape. I wonder what shape it is. Name the shape. This is a rhombus. How can you tell if something is a rhombus? Or a rhomb for short? Kind of looks like a diamond. A rhombus has all sides that have equal length. And opposite sides are parallel. And opposite angles are equal. So we know this is a rhombus. Now we need to figure out what formula to use. The formula for the area of a rhombus is 1/2 diagonal 1 times diagonal 2. Plug the numbers into our formula. We have 1/2 16 times 9. Since this half is right next to 16 here, I'm just going to half my 16 and get 8. 8 times 9 is 72. So then my answer for the area of this rhombus is 72 meters squared. What shape do we have here? We have here a parallelogram. How did we know that this is a parallelogram? Remember, a parallelogram has two pairs of parallel sides. And here we have two pairs of parallel sides. What's the formula to find out the area of a parallelogram? The formula to find out the area of a parallelogram is base times height. Isn't that easy? Step 3. Plug the numbers into the formula and solve. Our base is 14, and our height is 6. So the area for our parallelogram here is 84 centimeters squared. Let's review our learning goal. Our learning goal is I can calculate problems involving the area of a rhombus, trapezoid, and parallelogram. Let's do a few more examples. The seat of a bench is in the shape of a trapezoid with a base of 6 and 5 and a height of 1 and 5/10. What is the area of the seat? So we know it's a trapezoid. Now we need to use our formula to find out what the area of our trapezoid is. What's the formula for the area of a trapezoid? It's a half height is 2. Now if we look back at our notes from earlier, we can see the next thing we want to do is plug the numbers into our formula. So our base 1 is 6, and our base 2 is 5. Now we have a half times 1 and 5/10 for our height. So let's simplify our problem here. So 6 plus 5 is 11. A half times 1 and 5/10 is equivalent to 75 hundredths. 75 hundredths times 11 is 8 and 25 hundredths. So the area of our trapezoid bench is 8 and 25 hundredths feet squared. The kite in the shape of a rhombus has diagonals that are 25 centimeters long and 15 centimeters. What is the area of a kite? Well, we know the shape is a rhombus, so we can start with our formula. The formula for the area of a rhombus is a half 1, or D1, times diagonal 2. Now that we have our formula for the area of a rhombus, we can start to plug in our numbers. Diagonal is 25, and our next diagonal is 15. Let's start by doing a half times 25. Multiplying by a half is the same thing as dividing by 2. So 25 divided by 2 is 12 and 5/10. And 5/10 times 15 is 187 and 5/10. And since we're dealing with area, we want to square our unit. A window in the shape of a parallelogram has the base of 36 inches and a height of 45 inches. What is the area of this window? How do you know this window is a parallelogram? Answer the following question. Yes, that's correct. It has two pairs of parallel sides. There's one pair, there's two pairs. We have established that it's a parallelogram and why. Let's take a look at our formula and begin to plug numbers in. For the area of a parallelogram is base times height. In this case, our base is 36 and our height is 45. Yep, you guessed it, 1620. And since we're dealing with area, we want to make sure it's inches squared. Today we learned how to calculate problems involving the area of a rhombus, trapezoid, and parallelogram. Thanks for tuning in.
Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Here is a circle, it knows how to get around. It has a radius from center to rim, and its diameter's a line that goes from side to side while passing through the center. Now isn't that simple? Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d. Pi r squared sounds like area to me. When I need a circumference, I'll just use pi d.